Good afternoon, everybody. This is NCP. Before I get too far into this, I'm going to go ahead and do a video. Basically, I just made sure the power's off and pulled the outlet out, okay? Put the breaker downstairs. That's all I've done. That's 3 screws. One, this screw, that screw, and the cover. What we're going to do is we're going to put in a arc fault circuit interrupter slash, what you call it? Ground fault circuit interrupter. So, in this house, if I've missed something and it goes cuckoo, I don't want to fire. And so this is the most upstream fireplace over here, or circuit by the fireplace in the front room. The one downstream of this in the other area, which from the last video, or the video before last, is where the fire could have happened where it shorted. So this will prevent all that. And as you can see here, the circuit's dead. You know, nothing in there, no power. Well, that's out too, but you know, there's nothing in there, nothing live, blah blah blah. So we're gonna go ahead and put this one in here. I don't know if this will really fit in that receptacle. That's my issue there. See, it's about thumb joint. It should fit. Might have to push. I don't know. We'll see. We have to cut some wires. I don't know. We'll see when we get there because we don't know what's going to happen. But this will protect humans and the house from fire and shock, because it's upstream on an ungrounded outlet. I mean, not grounded. Okay, there's no ground in there, no ground wire. Yeah, no ground wire. So this is ungrounded. Code. I'll post the code below because I know people will cry about it, of where it's NEMA code to do this, or National Electronics Code to do it this way. So we're going to go ahead and pull these off, all screws off. Then I'll put some wire nuts on there. And I'm going to separate out the hot, which is the black ones, and I'll separate the white ones too. I guess the neutral. Neutral is what carries the power back to the transformer or whatever. It's your return. Not really. Your ground is if things go south. You know, it was a mistake. But this will, I forgot what I was saying. Sorry. Look. We're going to put this thing in. And keep us from shocking and starting fires. Oh, we're gonna lock off these outlets with wire nuts. And then we're going to take and flip the breaker on and find out which one's hot. We need to know what the line is. The line is the incoming current. And the load is the outgoing current. So according to code, and I'll post it below in the comment, or in the information, more information. The code says you can do this and it's safe and it's actually recommended. But if there's a problem downline, this will pop and it'll shut all the outlets downline off. So if I'd had this installed, you know, I got this at Lowe's. If I'd had this installed, it would have sparked and that would have shut it off. It would have, the one downline would have sparked and shut all the outlets off, and I've been done with it. Now, there is a problem with arc fault that isn't commonly known. Ham radio can set these off. Basically, they work. In the old days, they had a type of radio called, or transmitter called the spark gap, and this just did little arcs of energy, and it spewed radio waves all over the place. Well, these are basically little radio detectors, and I guess they use the line like antenna. I'm not sure, but you can check on that. But if your ham radio is keyed up, a lot of times you can take a little handheld and key up next to it, and I'll pop it. We'll try it after this. I'll get one of my handholds up there and see if we can pop it. But we'll see. But that can be a problem. A lot of ham radio guys have problems where they keep blowing their circuit breaker downstairs or wherever their panels are. And it's like, oh, I'm pulling too much power. You're not. It's the RF feeding back. So check your SWR. But your RF is feeding back into your house, and it's popping this thing because it thinks there's an arc fault. So anyway, let me get this undone. I'll just off camera. I'll just unscrew these, and I'll get the wire nuts on there. And then I'll go turn the breaker on, and I'll be right back once the breaker gets on the wire nuts. I'll be right back. Wow! I just went to unscrew this, and I put my screwdriver in. Let me get the other one. This slot. And Look at that. It was like that, so this is how much more I could tighten it. Completely loose. This one's tight. Let's see about the one over here. Tight. Tight. Okay, so this one here was loose up on the top. I hope that's not the line, but oh my goodness. Either way, there's current flowing through there. At least, well, we ran the heater last year, so at least 20 amps was flowing through this loose connection. I don't see any burn marks in anywhere or on here, so I don't know. But I'll be back once I get everything set up. And I'll mark this one. This is the top one on that side, so we'll see if that was the line. Oh, jeepers. All right, I'll be back. All right. Okay, so I believe these are the line, and I believe this is a load based on the physical location of the box, that everything downstream is that way in the house. And, you know, over there is, you know, the wall. But anyway, let me get back to you. Let me go power it up, and then we'll use our detector here. I'm sure I'll go like that and it'll light up, I'm pretty sure. Hopefully that's the only one lights up. All right, I'll be right back. All right, okay, I'm back. I suspect it's the top one up there. Let's see. This one, I think. Yeah, there we go, that's the line. So the line was a loose one. You know, I'm not a electrician. I'm an electrical engineer. But I do troubleshoot and help friends troubleshoot, but I mean, come on. You gotta know that, like I said, most house fires are caused by loose connections. So, alright, let me be back and we'll get this thing connected up. We'll be using clamps. Well, I'll come back to stab connections in a bit. I'll be right back. Let me go turn the power back off. Alright, I'm back. I turn this back on. Yes, alright, so we're going to verify everything's off. Do not like the electrical tickle. Also, it's an undocumented fact that if you have a basement and you're doing electrical work, you don't need to go to the gym because you've gone up and down stairs enough today. Ha. Alright, let me put this thing together. I should probably get a tripod, huh? Let me get a tripod. Guess where that's at? Yeah, that's right, in the basement. I'll be right back. Okay. Let me zoom in for you here. I don't see any, well, I don't really see any problems from heat. Maybe you guys will see something I missed. But, I think it was on top, right? Yeah, I don't see anything. Those are stab connectors back there. Stab connectors, where you push in, it's just basically held that little piece right there. So, yeah, stab connectors are basically held in by the little piece right there. So, I don't know. I don't trust them. I mean, if you're on a job and you gotta start popping things quick, yeah, fine, I would do it. But at my house, no, we're gonna clamp. We use clamps. And like I said, around the screw is fine too, but I don't like it personally. But that's neither here nor there. I think that's okay. So let me get the other thing out of the package and let's get to it. Oh man, I screwed up. I got the, come on, focus, dude. I got the protected outlets, the tamper resistant. I hate these things with a passion. You know, once I put something in the socket, it's fine, but you have to put things in exactly the right. Okay, well that just went in, but I have one on a carport out there, and I just hate them. They're really hard to get in, but this one seems. This one seems okay, but I've had so much problem with these things all my life. Well, not all my life, but you know, since I got them. So let me get this thing together. We're going to take the, somewhere it should say line up there. And we're gonna do the stab connectors. No, these are actually clamps. If you look in there, you can see it's a clamp. So that'll tighten down on it and it'll tighten the wire in there. It gives you full contact on the sides instead of just a thin slice. So we'll take the line and put on one that's probably on the top here. And the load will go down here. Zoom out. The load will go at the bottom, and that'll protect all the ones down line. And you know, we won't be using a screw, but we will have to put a sticker on here that they gave me that says no equipment ground or something like that. I think that's required. And I think you're supposed to put on all the outlets down line, but I don't have them. So what I'll do is I'll write the company, Eaton, and 9 times out of 10 they'll send you a bunch of stickers. So I'll tell them I need on this branch we got 1, 2, 3, 4. Wait, 1, 2, 3, 4, 5, 6, 7, 8. 8 that I know of. 8 outlets. So I don't know why I wouldn't do that. I'd have each bedroom separate, but you know, whatever. I didn't do it. So let me get these things put in. I'll put a black wire on the brass. For those using the gun community, it's hot brass. Simple. That's how I remember it. Hot brass. The neutral, and that would be the ground if I had it, but I don't. So let me go ahead and just wire this up, and that's really all there is to it. These two will go to the top, which I can't see. I'll have to get my glasses. I'm sure that says line up there, and down there I'm sure it says load. And it doesn't matter which of the two you stick it into. So let me double check that. Let me look at the things on this one, but yeah, I'll be right back. In case I'm wrong, let me read that in case I'm wrong. I'll be right back. Yeah, I was right. Do it like this, for just like an end of line branch. But if you do it like that, it's fine. It goes on just like I thought to the next one. The only time you put 2 on the top is if you don't want it to, when it pops, you don't want it to knock out everything else. So let's say you want to protect your bathroom with it, with a GFCI, and the missus drops something in the water and it conducts and pops a GFCI. You don't want to knock out the rest of the outlets on that branch. That's the only reason you do that. So we're going to wire this in series instead of parallel. Parallel would be it runs along with it and goes. So when this pops, the circuit's basically broke in the middle here, and all these become dead, which goes on to the next. These here goes on to the next outlet, which is dead. So let me go ahead and just get those in. Let me clean up those wires a bit with my my tool thingy. I'll check it with the thingy that goes beeps, because those are the technical names. No, well, the non-contact voltage meter. We'll go ahead and clean these lines out. Basically, just see, that's probably too long. There should be a guide on here somewhere for people that have like glasses that could tell me, but it's probably right there about how deep you want it. So you'll check it. Yeah, it's actually pretty good. So what we'll do is we'll just go ahead and put that in the hot up here, just like that. Just like that. And then you tighten it with a screwdriver. For people that have some type of dexterity, that wouldn't happen to, but I'm old and blind. Now, like I said, the important thing is to get that connection tight. So we'll tighten it. Then I always go back with another screwdriver, a slot on these, because I'm paranoid. I really crank that thing down. So that's good. Still a little loud, but we're going to wrap this in duct tape or electrical tape anyway, which that isn't required in code, but it's what I like to do. I'm just wondering if that'll fit in there. Yeah, it'll fit. But that push real hard, huh? All right, so let me get the rest of them in. I'll put the white over here, and then Yeah. And then I'll do the same for these on the other one. So these are the incoming or the line. All right, I'll be right back when it's all done. All right, so it's all wired up. We just gotta push it back in there, and hopefully it'll all fit. Let's see here. The wire's stiff, probably brittle. There we go. Oh wait, sorry, my bad. Screwed up. We're gonna wrap electrical wire around the outlet screws. It's not necessary. It's just a good idea. I mean, it's not gonna conduct, and I guess that's a metal box, but let me do this here real quick. There's gonna be a lot of complaining that I talk too much in this video. For those that have low attention spans, wrap wire or wrap tape and be done with it. So, I don't know. It's just what I do. Doesn't hurt nothing. And if anything, it makes things better. So, there we go. Just like that. So, there we go. Yeah, put it there. That's good. Good. Good enough. I'll have to back the screw back out, but that's fine. So let me back that screw back out real quick so I don't talk and think you guys watch boring stuff. Hold on. Alright, so we're good now. Now we just push it back in here. It is tight. So. Let's go ahead and put that on. Put this one in so we don't torque everything over torque it or twist it. Not even going in. There we go. That's not stripped down there. See, there are GFCIs that are thinner, and you know we don't have one here obviously, but they're a lot nicer to work with. A lot nicer. There. Hopefully we didn't screw anything up. An outlet. Did it come with the cover? Yeah, it did, so that's fine. Might be a little far away from the wall still. Might just be the screws holding it. So let me go ahead and power it up and test it before I put it back done there. Or finish it. Hold on. Alright, so it's on. Or not on, but I think it just dripped. I think you have to have something in it. Let's try that now. Oh, it tripped. So something ain't right. So, oh wait, maybe that's right. Is that on? I don't know. No. No, it's tripping in there for some reason, so let me figure out what's screwed up on it. And let me go ahead and read the instructions. Maybe it's because there's loads down line. Let me stop this and come back. Alright, what's going on is the GFCI. So we have, you know, blinking on for the red, and the amber was on or off. It was saying the GFCI self-test was failing. I mean, it's on right now, but if I pop it, that's it's saying it's tripped, okay, but if I go like that, it trips. But it came on again. Alright, well now it's passing, see? I think we'll probably replace this, I don't know. See, it's on, it's got power. I don't trust it, but I was holding it like that to get it to go, but That's right. Maybe it had to go a couple times, huh? I'll probably replace this. I don't trust it. I mean, the self-test is failure, and it's on the Gfci, but... See, if I go real quick like that, it fails. But if I hold it, it comes on. So, I don't know. I think I'll replace it. But that's how you do it. This one just happens to be faulty. And like I said, it's open ground. But this one's faulty. But... See? Won't go. On the self-test, it fails. But you can bypass it. So, we're going to go ahead and just replace this one, get a new one. But that's it. And you put the cover plate on, and that's the whole video. So, everybody have a good day. NCP out. We've gone on for 20 minutes and 56 seconds of me babbling, but we have an equipment failure here. So, there we go. We're going to replace it. So, have a good one, everybody. NCP out. Problems after problems.